Hi folks, Mike Fixer here again. Been a while. I finally got around to processing some boards I bought on eBay several months ago. I don't have the best setup here. I'm running my iPad camera in the other orientation since I know the vertical images, a lot of people don't like them. Anyway, so I'm in landscape now, and it's kind of messing up my field of view. But these are some Crystalab boards I bought off of eBay, and several months ago. And I don't know exactly what they are. I believe there's some sort of a high-end, maybe like for a studio graphic equalizer. They had multi-level knobs on them. I've already removed. Anyway, each board has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Each board has 14 of these gold top chips, and they're kind of unusual. I don't know if there's something they had custom made. They're actually, they just have a plain unmarked top on them, and they've placed a clear plastic sticker with the Crystalab name over the gold top. So, and I believe, I've got a board I stripped earlier, but they're kind of an unusual chip. They have quite a bit of gold inside of them, and I'm guessing there's some sort of attenuator chip that, along with the ganged switches and the other circuitry, is acting as a graphic equalizer. Again, that's my guess. But anyway, I'm going to start by, each board has 5 of these nice red switches with the gold contacts. I'm going to start by removing those. There's a chunky aluminum faceplate, probably 4 or 5 ounces on each one of them, that I can also sell for recycling. There's these ganged Gray Hill rotary switches. So what I'm going to do is I'll take some of the switches loose, and I'll take the faceplate off, and it's pretty easy. Just take the nuts off for both of those. Cut the wires off the switches. And then once I get to that point, I'll turn the camera back on, and we'll continue from there. Okay, so I'm back again. I can proceed a little further. That's the faceplate I took off. It's probably pretty close to 1/4 inch thick, and about 2 inches wide, and I'd say 10 inches long. Anyway, so it's kind of chunky. I've got 24 of these boards. I think they'll, I've already got 4 of them here. I'd say there's probably at least a pound there now. So I have a little bit of aluminum to sell. Alright, so I've got the faceplate loose from the ganged switches. I'll show you how to take one of those apart in a minute. Sorry, this picture gets a little grainy when the light level gets low. But let me see if I can get some more light. Do that real quick. Okay. May or may not help. We'll find out. We also got 5 of these switches off of that board, and these are, they're not Gray Hill. Okay, these are C&K brand, which I'm not familiar with, but they do have gold contacts. And try and get it on camera here. You see they're held together by those little folded over tabs. So if you can catch a tab, bend it out, I'm going to bend that whole side out and kind of, yeah, don't cooperate now. I wouldn't want you to cooperate. Okay. There's the inside of our switch. That's the mechanical portion of it. And where am I? Not used to the camera in this orientation. So we have our little contact that switches on and off. And then the contacts that the wires were attached to down inside the plastic. What I'm going to do is just reach in and cut alongside one of the contacts, and you can see the inner piece, the gold plating on it. I got a little more plastic left on there than I thought I would. Break that away. Okay, so there's one of the contacts, and cut away some more here. There's the second one. And the third one. So, there's all three pieces. Real easy. Let's see what's next. Alright, you may have noticed these pieces back here. These are actually the internal contacts for those Grayhill ganged switches. And these are kind of interesting because they each one of these contacts actually has an internal leg that goes all the way down to the base, and the whole length of them is gold plated, so some of those come way up here and all the way down to the bottom. I'll be taking some of those apart here. I don't always tell you the right tool for the right job, but I'm not going to go out and buy a little tiny nut driver just for 24 boards. So I'm just going to loosen these nuts on here. Get rid of that one. With loosen them with my cutters. I use these cutters for practically everything. Should probably know by now. And alright, well anyway. Once you get them started loose, as long as they're not binding, you can generally just grab the high spots with the and turn them. But alright, come on. It's going to fight me because I'm on camera. Or the screw may be turning. There we go. Got the other nut loose. Now, this whole piece here, well, you saw that little plate. They have a little silver plate on the back end. That just dropped off. This mechanism here is the ratcheting portion of the switch, which I have no use for. I'm going to toss that. And now, on the front of the switch, you have a sliding contact that gets connected to one of those contacts within the ring. I just broke that loose. And you put that back on camera. I don't know how well you can see it on there. They're kind of dingy looking and dirty, and little spots of corrosion or improper plating. I wasn't really impressed with those, but a little plastic spacer on the back end here, which doesn't get much use unless you added another section on. Now, on the back end, you see that little square shaft there. That would be to drive the next section in if you had multiple sections like you do in the middle there. Some of the pots have more than others. So in the front here, you've got this little rotating piece, and it's got a gold contact, which actually fell off. It's you can see it on the camera. It's actually sitting there on the edge of the board. I'll drop it on my hand. So you have that little fully gold-plated piece. That's one of the rotary contacts, and then you've got the ring, which is the static or stationary contact, and you've got the one on the other side here. One thing I'm going to do is on that back end, I'm going to take and remove that little square shaft. I think those are just brass. They don't, I mean, they're sort of, where's the, once again, sorry my lighting's not the best. They have sort of a goldish tinge to them, but not really. They look more like brass. But I'll hang on to them for now. And that was actually in a black contact holder, which is still sitting in a hole. You really can't see it very well here. So I'm going to take that other contact ring and bend it back to make some room. And you see I've got another slip ring contact there. So I'm going to reach in and take that loose and bring it out. You can see in that lighting a little better how ratty looking they are actually. But now that I've got that space in there, I can take the rest of this and this is the next ratcheting section, or detent, you may want to call it. Causes the switch to hold its position. Okay, now at this point I can just take and bend work hard in the contacts and just break it off even with the board. And then there's my inner rotary contact. This one actually stayed in a little holder. Oops, it just fell out. There it is there. I'll put that in my little paper plate here. I've got a bunch of parts over here in a paper plate. Some of them are from these switches. Some of these other pieces are from different Gray Hill rotary switches. Different type of them. I'll be taking a green connector off the board in a minute here, and these are pins from that connector. These are from those red switches and some other switches. One board had actually had a chip in a socket, and those are the gold-plated pins from that socket. And these are the rotary contacts and the switches. These are those little bars I told you about that kind of join the multiple sections of the switch, and I don't think that they're gold-plated. I think they're probably cheap brass or something. But anyway, I'll set that back out of the way. Now, I'm going to turn off the, well, let me show you one other thing. Crystalab has this custom module on here. Again, I don't know what exactly it does. Looking at the logo, I'd say maybe it's an amplifier or something. I don't know. But what it is, it's got a little circuit board in there. It's actually in the top end of that plastic box. And it's got some gold-plated pins that go downward into the board for mounting and contacts. And then it's got several discrete components that have been sealed in a block of RTV silicone. So that's actually what's inside that black block. And originally I thought, well, you know, I'd dig out the transistors and may have a little bit of gold in them, and I don't know. I think I'm probably just going to toss them, to tell you the truth. But anyway, I just want to show you what's in those. And on that board there's a green connector here with some nice gold-plated contacts. I'll be taking that off in a second here. There's also on the board several of these tantalum capacitors. The one farthest away in the picture there. That has the red mark on the end of it. It's actually the end sealed with red plastic. And so I'll be saving those. The things in front of them are resistors. I'll toss those. I'll toss most of these, like these yellow capacitors. They're polyethylene or something. They're garbage. Resistors and so forth. All these chips on here, they're all the same. All these black chips, I should say, are all the same part number, and they actually have some gold inside of them. I'll pull one or two of those off later and show you. And of course the purple chips there with the gold tops that have the clear label stuck over them are good to save. So let's see, let's get the screen connector off here. It's got one screw already missing. It's going to take out the other screw, mounts it. Okay, drop that out. And get these capacitors out of here. These are two of the ones I wanted to save. Set them aside. There are some tantalum capacitors that come in copper cans. These are not them. These are actually just electrolytics, and actually, if I remember correctly, I think just the plastic coating has that color. I don't even think they are copper cases, but I just want to get them out of the way. And so now what I can do here is I got two rows of pins on this connector. Once I cut the front one, that pin will move over far enough I can cut the one behind it. And now when I go to the second set, those will move aside so I can cut it and so on. So I'm actually doing two cuts at each row of pins. Normally I'd take everything off the board. I have a potentiometer there. It's kind of in my way, but I'm just working around it for now since I already jumped into the fire here. Just got 4 more pins to cut. There we go. Get the board out of the way again. So, here's my connector. What I'm going to do with this now is I'm going to cut away the side plastic. The nice thing about these plastic connectors of this color, the type of plastic is, oops, no, actually I didn't plan on doing that. The connector actually broke. It normally doesn't happen, but there's one of the pins right there. All I had planned on doing was I was just going to cut the plastic in the corner so I could break out these side pieces. Throw it in the trash. And then once you do that, you can get access to the pins and just pry them right out of the connector like that. So anyway, one way or the other, whatever works. But these type connectors with this green turquoise colored plastic are generally very brittle and friable. You can pretty much always crush it and get the pins out, although they tend to get messy sometimes. Pieces will adhere to the pins and so forth, but I just soon pull the pins out if I can. So, but I'll finish that piece later. I'll keep you waiting. Let's see. I'm going to make a little more room on the board so I can get at one of these chips. Let me put on hold again here. Okay, back again. I made a little space on the board here, remove some of the discrete components. One thing I hadn't noticed earlier is there's actually a one of the little globy shaped tantalum caps right there. So you want to save those too, of course. Oops, I'll get it later. And right next to one of these, it looks more like an electrolytic. But it has the red end on it. Anyway, I'll finish those later. So we have several chips on here. They're all Signetics, part number NE530N. I don't know what that is offhand. I haven't looked them up. I think maybe an op amp or something. So what I'm going to do is break a couple of them loose from the board here. And I'll see if I can get one cracked open well enough for you to see the inside of it. Okay, I got 3 of them there to play with. Set the board aside. Let's see. Got a smaller pair of end cutters here to work with. A little sharper edges on them. What I'm going to do is try and pop the top open on that chip so I can show you the inside. I'm just going to grab right along the middle seam and hold on to it so it doesn't fly all over. Okay. And we're actually looking at the bottom side of the die there. And again, I apologize for the light. So you really can't tell so well, but it is, the die itself is gold plated. And these are some of the pins, which I think you can see pretty well on the camera, that those are definitely gold plated on the inside of the chip. So there's got to be probably 20 of those on the board. I'm saving all those. And again, I got my tantalum caps, I got my gold plated pins and that green connector. I have several of those ringed sets of contacts from the different Gray Hill ganged switches. Plus I've got those little rotary contacts that were inside. I've got these gold top chips, which again, I showed you that one earlier on the other board that I'd already stripped. I'm believing there's some sort of a, I mean, it doesn't look like any other chip inside I've ever looked at before. I'm believing there's some sort of a attenuator or something that's used for selecting the different frequency ranges based on what's on that faceplate. If I can find it real quick here without keeping you waiting, I had one of these rings I accidentally broke earlier. Of course, I should have put it aside at the time and I didn't. Let me see if I can crack one here. Okay. Well, I broke one in half, but not much you can see as yet. Okay. There's one of the lower ones. It's kind of short. Obviously, as you get toward the top of the ring, they're much longer because they have to go around the side and all the way to the bottom. Okay. So now you can kind of see. There, I think I got it in the light now. You can kind of see how each of those contacts actually has a gold-plated connection all the way down to the base, where it was soldered to the board. So I'm thinking those may add up to a bit also at some point. But that's about it for now. Oh, I was just going to mention, when I bought these boards, I thought they were a little overpriced, but being that there were, 24 boards, and 24 boards, each of them had the 14 gold top chips. In the picture, I couldn't really tell what that square module was. I knew they had the gang switches, although I thought they would be a little different design based on my experience with other Gray Hill rotary switches. Even so, I think they turned out pretty good. I noticed the same seller on eBay has now got some other Crystalab boards that don't have the gold-plated chips. They have less of the gang switches on them, and he's trying to sell them for more than twice as much money. And I think it's hilarious because they've been up there now for several months. But anyway, that's it for now. Talk to you next time.